As you can see, our title changed a little bit, using contribution to growth curves to measure growth models. After listening and watching the presentations here, I feel that I have to say that we have a very modest article, a modest argument, but I think it could be an important one. I mean, what we are going to do here is very simple in a way. We are going to propose an alternative way to measure the relative contribution to growth. It's a very technical and not political, although both of us are political economists. The reason we worked on this project is because we wanted to find a more sophisticated way to measure growth model, but something that political economists can work with. I will go straight to the point. Currently, there are many different ways to operationalize growth model. Usually, most scholars use several indicators. But there is one indicator that all of us use, and this is the contribution to growth of a demand component and the relative contribution to growth of demand component. And what I would like to convince you in this presentation that there is some basic, substantial, and mathematical problems with the definition of relative contribution to growth. And I am going to suggest an alternative way. So I will start with this definition of the contribution to growth of the different demand component. Currently, it is widely used. It is often measured by official databases. It is defined as the rate of growth of the demand component multiplied by the ratio of the volume of the demand component divided by the GDP. The problem with this indicator is that it does not allow you to compare different growth models in different countries or in different periods because it is not normalized. So in order to normalize it, what we do, we divide it by GDP growth rate. And therefore you get this definition of the annual consumption relative contribution to growth defined as the change in the demand component divided by the change of GDP. I mean, this is obvious. I mean, you all know it. Now, I'm going to argue that there are three types of problem associated with this definition: the problem of zero growth, the problem of spillover, and the problem of dynamics. In order to explain those problems, I'm going to the basic, to the mathematical way by which those definitions are derived. So we start with a well-known Keynesian model, which presents GDP as the sum of the demand component. And then it is quite easy to move from that equation to equation one, which represents GDP growth rate as the sum of the different contribution to growth of each demand component. Now, in order to move to the equations of the relative contribution to growth, equation two, we divide both sides of the equation by GDP growth rate, and then we get that the sum of the relative contribution of growth of each demand component is unity, is 1 unit. Then the next stage, we separate this equation to different elements, and this is the definition of the consumption relative contribution to growth, investment, RCG, etc. And then the next step is to calculate the periodic average of relative contribution to growth by simply calculating the average. Now, what is the problem with this method? So as I said, there is the problem of zero growth, the problem of spillovers, and the problems of dynamism. So let us start with the problem of zero growth. When we move from equation 1 to 2, when we move from the equations of contribution to growth to the relative contribution to growth, we divided both sides by GDP growth rate. But what happens if GDP growth rate is zero or very close to zero? In this case, the outcome is, the results is infinity, and it distorts our results. The only condition it would not be infinite is if each variable on the right-hand side is 0, 2. And as I will show you later, this is not the case. So the problem is distortions when GDP growth rate is very low. The second problem is the problem of spillovers. When we move from equation when we move from equation 2 to equation 3, yes, we separated the elements. We assume that there are no spillovers. We assume that there are no spillovers of, for example, from consumption contribution to growth to export, import, or whatever. And given that, as I will show you, there are spillover, basically this definition does not hold. The third problem is more philosophical, I would say, but this is the problems of dynamism. When we calculate the periodic average of relative contribution to growth, what we are calculating is a point that represents some kind of average, but we lose a lot of information regarding the distribution of the point, what happened when GDP growth rate changes. So this is why this indicator is static, and it doesn't answer the questions what happened if GDP growth rate increases or decreases. So given these three problems, we wanted to offer a different approach. So in order to convey to you what we are doing, in our paper, we choose to go to demonstrate it graphically, because we are talking not only to economists, and a graphical representation is more easier. So first, let me show you what we do when we use the conventional way, graphically. So let us plot a coordinate system in which the horizontal axis represent the contribution to growth of each demand component, and the vertical axis represent the growth rate. And then for a specific year, we have a specific contribution to growth and a specific growth rate. And then the slope of this line represent the relative contribution to growth. Okay, and when we have several years, when we have a period, basically this point represents some kind of average, and again this slope represents the average relative contribution to growth. Now, this approach tacitly assumes that if growth rate is decreased by half for a second, the relative contribution to growth also decreases by half, which means we assume here linearity and proportionality. We assume that there is a constant proportion between the contribution to growth and GDP growth rate. What we are doing, we suggest that a linear relationship between contribution to growth and GDP growth rate, but we don't assume proportionality, which means we have like a curve, a line, but we don't assume that this line has to go through the origins. So we define the slope of this line as the dynamic relative contribution to growth. We define the intersection point as the spillover factor, and we define this slope, this is the average point, as the static relative contribution to growth. Now, after presenting this definition, let me explain each of them. So the dynamic relative contribution to growth capture the change in the contribution to growth given a 1% increase in the GDP growth rate, which is this. So this is the proportion. What happens when you increase GDP growth? What would be the increase of the contribution to growth of each demand component. And this is why I call it a dynamic. It is not a static one. Now, the spillover factor, which is this point here, the intersection of the trend line with the y-axis, basically it shows us what is the contribution to growth of each demand component if GDP growth rate is 0. And I define it as a spillover factor because this is the proportion of the contribution to growth that spill over to a different demand components. Now think about it, when it is negative, it means in this case, consumption spills over, for example, to import. When it is negative, it means that it sucks demand power from other elements. Okay, the third one is the static RCG. We still think that it is also important to measure the static relative contribution to growth because it represents where the economy lies along the curve, because we can have two economies with the same curve, but one of them is here and the other one is here. So the performance within the same line with the same curve, you can have good performance and bad performance. Now, another contribution of our measuring approach is that we also measure the robustness or the coherence of the model, because imagine that if you look at case B, the dots are very close to the line, which means our assumption of linear relationship holds very strongly. In other cases, the dots are distributed and the linearity assumption doesn't hold, which means the correlation is very weak. So despite the fact that you have an average point and you have a slope, the assumption of causality does not hold very strongly. So to sum up, what we are offering, instead of one indicator, we have five or four indicators: the periodic dynamic relative contribution to growth, static periodic static relative contribution to growth, spillover factor, and those indicators that capture the coherency of the model. Now, before I present the empirical finding, I would like to give you a few examples in order to get the intuition of our approach. So this is an hypothetical case of two countries, A and B. Country A, you have a positive dynamic relative contribution to growth, and the country B is almost horizontal, which means the dynamic relative contribution to growth is 0. Now, both countries, if you use the conventional way, have the same average, the same static relative contribution to growth. But in country A, you can see that an increase of consumption is correlated with an increase of GDP. But in country B, you cannot achieve higher growth by increasing the consumption because you would move upwards. So either there would be, you move all the line upwards, or it would be just a statistical movement below and above the line. So in that case, you cannot achieve higher growth by increasing consumption. This is a second demonstration. Here we have the net export curve. The net export curve, and we have three cases. Country B with a positive dynamic net export RCG. In that case, there is no trade-off between improved trade balance and improved growth. So the country can achieve both. This is often the case within the European Union. As you will see, there is no trade-off. Now, in other countries, they have negative slope. And for example, this would be the United States, and this would be Korea. So what we see is that those countries face a trade-off. They have to choose between more growth and improved improve trade balance. And we think this is one of the key contributions of our approach because it provides an explanation for austerity policy. Basically, this, in order to go here, if this is the model, this is a kind of austerity policy. When we interpret these curves, this approach also allows to distinguish between two types of changes. One change is you can move along the line, which is a kind of changes within the model, because the dynamic and the spillover factor, the dynamic RCG and the spillover factor stays the same. But in another types of change, which is the change of the movement of the line, which we would interpret as a change of the model. Okay, so now the purpose of this article was not to study new state, but rather to calibrate our approach. So we chose countries which are highly studied, and what we wanted to see what kind of insights our approach brings in. So we focused on those 6 countries before and after the crisis, and we measured consumption, export, and net export. And for each demand component, we measured dynamic RCG, spillover factor, static RCG, and R-square and p-value. I will start presenting the finding. When I come to the end of my lecture, please remind me and I will wrap up. Okay, so first, Germany. What we see in the case of Germany, that after the crisis, the dynamic consumption RCG was almost 0, which means, according to our understanding, is that in that period, Germany could not achieve higher growth rate by higher consumption. And this is a difference from the pre-crisis era. When we look on export, our approach confirmed the conventional wisdom that Germany is an export-led growth country, and we see also an increase in the dynamic export RCG, and we see that in both periods the model is very robust, p-value is very low. In terms of net export, here again we see an increase from 0.11 to 0.27 of the dynamic net export RCG. And we see also that in both cases, the slope is positive, which means Germany can achieve both growth and improve its external balance. The United States, again, we confirm the finding that the US is a consumption-led, but we had few nuances here. In both periods, the consumption dynamic RCG was 0.47, but what we see that the model became less robust, which means less correlation, weaker correlation between consumption and growth. When we look at export, before the crisis, the correlation is the dynamic RCG is low, but the model is robust. After the crisis, the dynamic export RCG is very low, almost 0, and the model is not robust, which means that in a way, the United States, after the crisis, did not have a very solid model at all, because both in consumption and in export, it driven away from a robust model. And not surprisingly, net export dynamic RCG is negative, which means a trade-off between growth and a balanced trade. But after the crisis, the numbers are very high, which means the trade-off after the crisis is much more significant. And again, this confirms that after the crisis, the United States in a way lost its way. Sweden, again here we confirm the convention that Sweden had a quite balanced growth model, but after the crisis, in terms of consumption, it had before and after the crisis a medium level dynamic and static relative contribution to growth, and both, and also in terms of export, before the crisis, dynamic RCG was 0.94, very, very high, and after the crisis, it was 0.61. In both cases, the model is very robust. And in that sense, I think what we see here, that it would be not precise to describe the Swedish model as a kind of a balanced one. Basically, they did very well, both in terms of consumption and in terms of export. When we look at the net export, the dynamic RCG is 0, which means no correlation between net export and growth. No correlation between net export and growth, and this is it distinguishes the Swedish model from the German. Ireland, I think this is the last country. Before the crisis, we see consumption, relative contribution to growth 0.25. After the crisis, it comes to almost 0, which means they shifted away completely from consumption-led growth, and obviously they are shifting towards an extreme case of export-led growth model, from 1.3 before the crisis to 1.6, which is very, very high after the crisis. In both cases, the robustness of the model is highly strong and robust. In terms of net export, in both cases, very positive, 0.35 and 0.76 after the crisis. So very strong correlation. Korea, sorry, this is the last one. Korea, here we have some interesting findings. So before the crisis, Korea was consumption-led growth. Consumption-led growth economy, 0.88 in the dynamic way. And here, look at that. This is negative spillover factor, which implies that consumption sucked a demand power from other demand component. After the crisis, the dynamic consumption RCG is much lower, and in both cases, the model is robust. In terms of growth, look at that. Before the crisis, the dynamic RCG, the export dynamic RCG is almost 0, but the static RCG is positive, which means export did not contribute to consumption. This is it is changed after the crisis, when the slope becomes very almost 1, and the model is quite robust. When we look on net export, before and after the crisis, we have negative slope, which means Korea faced a trade-off between export and growth, which is not surprising. And here, before the crisis, the model is quite robust. So
it's almost done.
This is the end. So I just very quickly, what are the contribution of this approach? So we distinguishing between, it enables us to discuss the difference between dynamic and static elements of the model, distinguishing between change within the model and change of the model, like the movement of the curve, conceptualization of the interaction between demand components, the spillover factor, distinguishing between types of consumption-led models. In one case, high dynamic consumption RCD versus horizontal consumption RCG curve, distinguishing between types of export-led growth model, positive versus negative dynamic net export RCG, and the estimation of coherency and robustness of the model. And finally, it's quite simple to handle. One downside of our approach, we don't have a theory. We don't know what are the economic fundamentals that explain the differences between the curves. Thank you very much.
Thank you.